All right, so today is another lesson that I think you guys will like comparative to our last chapter. So today we're discussing permutations and combinations, which I reference a lot of times. What did you say? Yeah, right? Because I reference this a lot of times. I don't want this page. It's got the application parents decided to show up. What is the difference, does anybody know, between permutations and combinations? You don't have to know which one's which. Just what is the difference? Liam, your hand is up first.
Okay, permutation is where order matters and a combination is where order doesn't.
So can you give me two examples?
Okay, for example, like on your locker, it has to be that your numbers have to come in at the right, you have to put, you can't, like let's say your digits are 1, 2, 3, you have to put it in as 1, 2, 3, you can't put it as a 3, 2, 1.
Yeah, so when order matters like a combination, if I'm typing in numbers for a combination or a password, order matters. What's a situation, Jacob, we talked about this yesterday in Math Council, what's a situation where order doesn't matter?
So if you're ordering a pizza and then you have topping, like you can choose what toppings you want, the order of what you get them doesn't matter.
Yeah,
So
if you're ordering sausage, pepperoni, and mushrooms, or mushrooms, pepperoni, and sausage, or pepperoni, mushrooms, and sausage, it doesn't matter what order you place the toppings in, they're all going to end up on your pizza, and they're all going to end up in your stomach. So, when we talk about permutations versus combinations, that's the big difference, whether or not order matters. So in chemistry class, you and your lab partner must add the samples in the test tubes to a mixture, which always scares me because some of you guys, I think, would intentionally try to blow up the room. The reactions that occur depend on the order in which you add them. How many different ways could you add these samples to the mixture? So you've got 4 samples. If we call these A, B, C, D, and we're trying to see what happens as I add them, what's the simple, when you think about the order of which you could add them, what's the easy one that pops in your head? A, B, C, D, just in order, right? So we could place them in A, B, C, D. That'd be one way to order them. I could also just reverse it, is normally the second way. D, C, B, A.
this is gonna take a while.
Ooh, it is going to take a while. So if I don't want to list all of them out, I really can start thinking about this critically, because as Grant, thank you for stopping me, because I was just going to keep going until somebody said something. As Grant said, this would take a very long time. So think about, you're adding 4 different things into a mixture. Olivia?
So you have to. So you have to. So the first one that you add, you have 4 choices. So first you multiply 4 times the next number, which you have 3 left over. So you come from this 4 times 3 and 2 times 5.
Yeah, this is when like choice comes into play. How many choices do you have? In my first addition to the mixture, the solution, I have 4 choices, 4 chemicals I can choose from. When I go to add my next one, if I've already chosen one of them, I have 3 chemicals. When I go to add my next one, I have 2. And at my last one, I only have 1 option left. This is where the fundamental counting principle is derived from. What's 4 times 3 times 2?
24.
24, right? I would have had to list out 24 different ways of adding these mixtures if Grant hadn't stopped me. So you guys all owe Grant about 3 minutes of your life.
Thank you, Grant.
Yeah.
Okay.
I know, it doesn't.
Okay, so stretch.
No, I'm confused and I'm trying to think how to word my
I
question.
think you're stretching it, Mr. Hudson.
Oh, that was really bad.
You're getting punched.
Yeah.
He's getting punched.
You too, Wyatt.
Wyatt, you're contributing.
Hey, we brought this action, not the problem.
All right, here, this will hopefully help by looking at the key concept. Here's the key concept. These are the 3 basics that you need for this lesson. If you're just looking at options and things that you can order, like when you go through the lunch line, and I should actually go look at these things, make a real situation. Say that you had 1 entree and 1 drink. You get your choice out of 4 entrees and your choice out of 6 drinks. So your first option that you have 4 choices. Your next option that you have 6 choices. because my first option and my second option are not related. In the addition of the chemicals, they were all related. So I just say I've got 4 choices there, 6 choices there, I multiply them, and I get 24 possible lunch specials to make. The fundamental counting principle really just says take the amount of options that you have for your choices and multiply them together. Then we get into when we care about order or not. A permutation is a situation, not a premutation, because that sounds really weird. A permutation is a situation where the order matters. Like if I'm shelving books in a library, the order matters because they have to go by the Dewey Decimal System, or if they're, nonfiction gets sorted by author's last name?
No.
Or vice versa?
Yeah.
Yeah, fiction's author's last name. So nonfiction would be Dewey Decimal System, fiction would be alphabetical.
What are the exclamation points?
Ah, thank you. What is it?
Factorial.
Factorial. So what that means, and here I'll give you a little example to throw in your notes. It's an easy one. 4 is not 4. It's 4 factorial, which means 4 times 3 times 2 times 1 means multiply down to 1. Multiply by all the numbers between it and 1. Although in golf, if someone yells 4, you should duck because it means something's coming at you.
Or they saw a dog.
So, hold up.
Yeah,
Hang on to it for a second.
Stay duck for long.
You done?
Yeah.
Okay. So, here, this order matters, but every time I place an item on the shelf, like think about the book shelving reference, I now have one less item to choose from when I go to pick my next location. So that's why then we divide by n minus r factorial, because it says a set of n items arranged in, a set of n items of a set arranged r items at a time. So we say we have a certain number of books and we want to put a certain number on the shelf in order. So this stops us from over counting. The division on the bottom gets rid of all those situations that can't occur because we've already done something. This will make more sense as we get into realistic situations. Combination, you're going to have more options because this is like when you order pizza and you're placing those topping orders. So what we have is n items choosing r at a time. So when we talk about combinations, we will call this n choose r. It is, the C represents a combination, but a lot of times we'll say 8 choose 5. Or here we have 9 choose 4. I have 9 items, I want to choose 4 of them. So imagine if you had a group of 9 people, say a club after school, and you want to pick a 4-person group to go talk to Mr. Sherg. Doesn't matter who's in that 4-person group, doesn't matter who is what position, you're just a 4-person group to go talk to somebody. A permutation would be like if you had a group, a club after school, come back to this one, let's say you had 8 people in the club and you wanted to pick a president, a vice president, and a secretary. Once you've picked the president, he is no longer an option for the vice president. Once you pick the vice president, neither of them are an option for the secretary. So that's why you'll get a smaller answer in that situation because you then have less choices or options, and order matters. It matters who's the president, who's the vice president, what position are they in. So if we go to a deli offers a lunch special if you choose one item from each of the following menus: sandwiches, sides, and drinks. Well, how many sandwiches do we have? 6. So my first option, I have 6 to choose from. My next option for sides, how many do I have to choose from? 4. And my next option, how many drinks do I have to choose from?
5.
So we're applying the fundamental counting principle here. We're just taking options times options times options. And we could have a possible 120 different combinations at this restaurant. Oh, my apologies.
Yeah.
I just normally do that to list option, option, option. I'll capture it again with a line. There we go. So try this. You are writing a password.
What just happened?
His hand is raised even while he's walking in the room because he thinks it's going to matter. You are writing a program and both of you gentlemen with your hands up, I would not put this past you to try to crack a password.
Oh, I've done that.
It begins with a letter followed by 2 digits. So the same digit can be used more than once. How many different passwords could this computer generate?
I'm waiting in line. That's more special.
It is a good point. He is more special.
You guys absolutely make me not want to just call on people. Grant, got an idea?
I got an idea. Greg has an idea.
You can pass it off if you want.
Okay, so 2,600.
Wait.
What?
Yeah,
It is.
yeah. 2,600.
I need to know how. If there's something you should know about me by now, it's I don't want the answer.
There's 26 letters.
26 letters possible.
There's 10 numbers.
10.
Yes, there's 0. You have to
0 is a digit. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 options.
And then since you can use them twice, it's another 10. So you get 2,600.
A letter followed by 2 digits. Do you want to check it and verify if Greg's doing the right thing?
Does that have to be a 2-digit number or just 2 digits?
No, 2 digits. It's gonna end up as a 2-digit number, but 05 is a 2-digit number. It just has no value in the tens place.
I see now. I get it.
So, again, verify. What was your answer that you found? 2,600. Verified by this. What you want to think of is letters have 26 options, numbers have 10, and again, numbers have 10 because they can be repeated. Now, if it said that digits could only be used once, then this would actually have to be a 9. So this turns into 2,600. What are you asking? If it said that digits couldn't be repeated, like you couldn't have 11 or 22 or something like that, then that would turn into a 9. But because we can repeat, it stays 10. Leon, question?
Oh no, I have to got it. Wasn't that the got it?
That was the got it.
Oh, the next
There's a
one.
problem to got it.
I got the next.
That's like in 2.
So the first permutation I have solved out for you here.
Jacob.
So you can download 8 songs on your music player, and if you play the songs using random shuffle, how many different ways can the sequence of songs be played? No, I did not yet. It's solved out in your paper though, so I'm just gonna go ahead and show it. So we know that we're downloading 8 songs. When my playlist starts generating what song it plays, the first song it has 8 options, the next song it has 7, the next song it has 6. And actually, music players are written with the code so that it knows to not play the same song again. It kind of has a code that says without replacement. It says you don't want the same song to come up on random if you haven't listened through the whole playlist yet. Now, if you listen through the whole playlist and it still keeps going, then it will probably play the same songs again and then in a different order. So there are actually 40,000 different orders that those songs could be played.
Okay, I have the next.
Ben!
You do 12 times, 11 times, yeah, so on, and you would get 479,001,600.
So you really just did 12 factorial, right?
Yeah.
Which is 12 times 11 times 10 times 9 times 8 times 7 times 6, all the way. Now, so you don't have to do all that annoying multiplication. There's a factorial button.
Where?
This one too.
What?
I think there was.
So, if you have a TI-83,
Oh.
if you have a TI-83, what you want to type in is 12, and then go to math.
There's one on the P.
Oh yeah, there is one on the iPhone. If you have a TI though, which guys, this is the calculator you're gonna use on the standardized test in the spring. So do not say, oh, my iPhone has one, I don't need to pay attention. You won't have your phone for that test. On these calculators, you have to hit math, go over to PRB, which stands for probability, and option 4 is your factorial.
The little exclamation point.
Little exclamation point. So then it should spit out the answer, giant number, 479
Yeah, I was
001 600. So we have 479 million ways that these books could be shelved. Yo.
What? Like, okay, so
That would take forever.
Never mind.
Try to formulate it into words. I'll come back. All right. So now to situations where order is important. So not a random playlist, not shelving books, and not caring about order. We want order to be important. So that base start number, that like 12 factorial or 8 factorial, that is what is in my numerator of a situation. Then I divide based off only needing a certain number of situations. So the environmental club is electing president, vice president, and treasurer. How many people are in the club? 10. How many people are we choosing, or how many positions are we filling? 3. Does order matter?
no.
No.
Yes.
Yes.
There's different positions, right? President,
Yes.
vice president, treasurer.
Wait.
So order matters. This, you should immediately think, is a 10 permutation 3.
How can we tell if it's like permutation?
Because if it said you're choosing 3 people to just be the execs, then it doesn't matter who's, like, there's no positioning. There's just 3 people. So you have this on your paper, so I'll go ahead and pull it up. You would put your 10 factorial on top. Guys, I'm using cards now. Like,
No, I just had something.
How do you do that factorial thing?
If you're 10,
Math.
go to math.
over to the right, option 4. Over to PRB for probability.
Where's math?
Sorry, Leon.
To save time with the factorials on that, if it's 10 factorial over 7 factorial, you can just do all the numbers in the factorial, excluding the
Yeah,
stuff
you
after
essentially took the
7.
words right out of my mouth. So, take this situation. Because your denominator comes from the difference, like how many people or how many places have not been chosen. So if you are choosing 3 people and you have a 10-person organization, 7 aren't getting chosen. So this is really 10 factorial over 7 factorial, which if I drop this solution down, this 10 factorial over 7 factorial is 10 times 9 times 8 times 1, like all the way down. And 7 factorial is 7 times 6 times 5, all the way down to times 1. These can cancel out, and all you really have to do is 10 times 9 times 8, which should give you 720. There are 720 different executive councils that could be formed for this club. And that's only with 10 people. So this really starts to show you like how many options there are with like certain outcomes. Like our presidential election right now, there are lots of outcomes that might happen because there's no primary candidates chosen yet. We've got front runners, but we've still got way too many options to really be able to talk about. It could be option A or B or C or whatever.
John Kasich is second for New Hampshire.
Bernie Sanders won New Hampshire. I'm happy to hear about that.
Yeah.
12 swimmers compete in a race. They're going to finish first, second, and third. Wyatt, what kind of situation am I setting up?
So 12p, 3. How do you say that? You say
12
P3.
permutation 3. It's so really it's like a 12 choose 3, but because we have to say it's a permutation, we don't normally say choose. You could say 12 permeate 3 or permutate 3. I don't know exactly how we would say it.
And equals 12 factorial over 12 minus 3 factorial.
So here, how many people aren't finishing first, second, or third? 9. So really my 12 factorial over 9 factorial, I can simplify this down to 12 times 10, or sorry, 12 times 11 times 10, and that's it.
Wait,
No,
1,300.
1,320.
Yep.
Is this making sense? So permutations should give you less options because order matters.
And for the second one, order doesn't.
For combinations, no, order does not matter. So flipping to the next page.
And that's why we multiply by.
Sorry, this doesn't have a header. I didn't have lots of space when I was doing this. So this is problem 4 now. So, suppose you choose 4 books to read on summer vacation. Does the order in which you read them really matter?
Not really.
No, not unless they're series, which that's, not here. So how many different combinations of books are possible? This is like a summer reading program. They give you 12 books and they say read 4 of them. Well, if order doesn't matter, I have 12 factorial options, but since I'm only choosing 4 of them, I'm going to set up 12 factorial over, but now that's a combination, I'm going to have 12 choose 4, and now my formula changes. I have 12 factorial on top, and I still have my 12 minus 4 factorial on bottom, but there's something else on bottom too. What's that?
The number that you're choosing, so 4 factorial.
So you have 12 factorial over 4 factorial times in your denominator, and really, I like to rewrite this as 12 factorial over, and this is when especially I started making my ones like that, when I got into factorials, and I had to keep straight what was a 1 and what's an exclamation point. I don't like how this looks. It almost looks like absolute value of 2. That's why I started making my ones like this. Like really, if you guys want to know why I do that. So this should always, the numbers on the bottom should sum to the number on the top, before you solve it obviously. But this should be how many you're choosing, and this should be how many are left over. Because we have to get rid of all those, that's why we're dividing by that. So then what's interesting here is the 8 factorial will cancel out the 8 factorial from top. So I really have 12 times 11 times 10 times 9 over 4 times 3 times 2 times 1. So when I solve this out, yeah, and you guys have it on your paper. But notice how much easier it is to think about it like this than to think about it like this. It's way simpler to evaluate, okay, 8 all the way down to 1 will cancel out this 8 all the way down to 1, and I really just end up with 12, 11, 10, 9 on top, and 4, 3, 2, 1 on bottom. And of course, the 1 never really makes a difference. If you have 495 different sets of books that you could read. Yep. Service Club is 8 freshmen. 5 of the freshmen are to be on the cleanup crew for the town's annual picnic. How many different ways are there to choose 5 members to clean up the crew? Raider? You can always pass it off. McKenna? So what is my, it's going to be...
So you're choosing, you have 8 options,
Yep.
and then you're choosing 5.
Yep, 8 choose 5. So then my numerator should be 8 factorial is how we call it. Then, it doesn't really matter what order you do it in, but you're going to use the difference between them factorial and the choose factorial. So we really start with the 5 factorial and then have 8 minus 5 factorial. So this becomes 8 factorial over 5 factorial times 3 factorial, which really, when I cancel things out, I get 8 times 7 times 6 over 3 times 2 times 1. And to show this out, 56. So this is a good example for when we talk about, let's say we chose the dodgeball teams. I see fear in your eyes. if we chose the dodgeball teams, let's stop for a moment. This is not on your paper. Because we have a canteen on Thursday, how many students approximately do we have in Phoenix? 160, right? And really we have about 165. So we have 165. Would the order of the team matter? No, you just have 5 people. It's 5 people, right?
Yeah.
So we'd have 165 choose 5. How many different 5-person teams would be able to be made?
Oh my god.
Now this gets really annoying to compute, right?
Yeah.
That's why your TI-83 can do it for you.
Couldn't you just do
You sound like an
165
excited
factorial
student.
divided
Because it is really exciting. I was waiting for somebody to get really annoyed. I was hoping to have one of those moments of like, gosh, isn't there a way for the calculator to do this?
Hudson.
So, if you've been going over into the math menu, what else do you see in the math menu above factorial?
I see some math options.
165 factorial error.
Check it out. Go to math. Go over to PRB. Look at this. NPR, NCR. So, if I go to a choose option, it's going to try to grab the first number. So I cannot just pick that. I have to first tell it how many options do I have. So I'm going to clear this out. If we have 165 students and I want to do a combination and choose 5 people, we really have, if we chose the teams, we would have 958 million different teams that could be chosen. So, what would be the probability that you would get the 5-person team that you want? It'd be 1 in almost 1 billion.
That's like worse.
If we chose the teams, your probability of getting the team that you want would be like 1 in 1 billion.
I guess it'd be much
Hey, Mr. Hudson.
Yeah.
And then if we did it on the board, it'd be even higher.
I will be here to DJ.
Aw, man.
Wait, are we gonna do a lip sync battle?
Yes.
Yes, I love that.
That's so fun to watch.
There's going to be sign-ups. I don't know if those have happened yet or if those are happening tomorrow, but there will be sign-ups. All right. Now we got to decide situations. We got to decide whether it's a permutation. Hey, guys. We got to decide whether it's a permutation or combination. A college student is choosing 3 classes to take during the first, second, and third semester from the 5 elective classes offered in his major. How many possible ways could the student schedule these classes? Would this be combination or permutation? Leon?
It would be a combination because this isn't like his actual schedule. It's more like what classes he's taking.
Anyone argue the other side of it? I mean, that's the problem with some of these situations is you really have to analyze, is the order of choices going to actually like think about ordering books on a shelf.
Oh wait, it says schedule.
Oh, boy.
I didn't see it.
Did I solve this? No, I did not solve this out. So, the order in which the classes are chosen does matter, right? It matters what he takes first semester, what he takes second semester, and what he takes third semester. There is a sequence, there's a schedule, so the order does matter. So we want to use a permutation. So that on your paper, notice it says order does matter. We should use a, and then it has nothing after that. We should use a permutation. So this is a 5 permutation 3 because we're choosing 3 classes. That'd be a 5 factorial over a 3 factorial, which would really just be 5 times 4. So really there are 20 ways he could choose his classes.
That's a lot easier.
Permutations are easier because there's less options. Oh crap, I forgot to do the subtraction. My apology. It's not over straight 3, it's over 5 minus 3, which gives me 2. That's what happens when you skip steps.
So it's 18
No, it's 60.
or 16.
Because this becomes 5 times 4 times 3 over 1.
Because it's 5 minus 6.
Hey, do not make the mistake that I made. Write down your subtraction because I was moving quick and tried to not write it down. It's always your 5 factorial over 5 minus your choices factorial. So that's really over 2 factorial.
Equals.
What about?
You wrote 60.
It is 60.
It is
It is
60.
60.
Because it's 5
They become 5 times 4 times 3 when the 2 and 1 cancel out. A jury. You guys don't know a lot about the judicial system necessarily yet. A jury of 12 people is being chosen from a pool of 35 potential jurors. How many juries can be chosen? Okay. What do we use? Permutation, combination.
I use combination.
Why?
Because it doesn't matter the order of the jury necessarily. It just matters like who is being.
You're not like the jury president or the jury secretary. You're just on the jury. So it doesn't matter the order. You're just in the jury. So it'd be 35. Choose 12. So when we set this up, 35 factorial over, or we're going to have the difference between them and the number that we're choosing. So we're going to have a 12 factorial, and then we're going to have a 35 minus 12 factorial. 35 minus 12 is... But then again, guys, let's use our technology to our advantage. So if I want to solve this using my TI, all I have to do is type in my 35, go to Math, Probability menu, down to a combination, and then choose 12. We get a giant number. Is that million? Yeah. 834,451,800. I've still never had to be a juror.
That's good.
Yeah, I mean, when I got called for jury duty from my hometown, I was at college, and if you're going to school, like, you normally get waived. Yeah.
Our Jacob and my EPP teacher in like 5th grade got like called to jury duty.
Yeah.
Several times.
Yeah, it was pretty swag.
Well, sometimes it's the same case, just continuing on and on. Like, they'll meet one day, and then they'll, take a recess for multiple days. Try this out. This one should be easy to determine permutation or combination because you're at a yogurt shop choosing 3 of 10 mix-ins. So that's our like base bowl is you get 3 mix-ins.
Can you pick the same one twice?
No, that'd be stupid.
No, because then you'd still have only made one choice. They just might double it. Leo, what kind of situation is this? Permutation or combination? We're choosing toppings for a yogurt.
I put the combination.
Yeah, it's a combination because order doesn't matter. It's toppings. So we would have 10. Choose my 3. 10 factorial over 3 factorial. And really, I can just do the subtraction in my head. 7 factorial. So this really becomes 10 times 9 times 8 once the 7 cancels out. Or 3 times 2 times 1.
Well, this is a mind boggler.
What'd you get?
That's like
120? 120 different 3 mix-in yogurts.
That's pretty mind-boggling.
So now I want you to look at your notes for a second on the no. It's like pulling from a bag or something like that. So check this out on your notes. I have the solution done out for you in your notes. So when we think about probability of events happening, we have the billiards balls 1 through 15. If you ever played billiards, that's why 8 is like a neutral, because there's 7 of both color, and then like 7 solid, 7 stripes, and then 8 is kind of a neutral. So number of possible ways to choose 5, 7, and 9. So how many possible ways we could choose those 3 outcomes? We use the fundamental counting principle there because I don't care about the order. I just care that I've chosen 5, 7, and 9. Order's irrelevant for that. So 3 ways to pick the first ball, as I have 3 options. 2 ways to pick the second, and 1 way to pick the last one, assuming that I've chosen the ones that I already want. So then I really set up this situation is a 15, choose 3. So I have 6 ways to choose what I want out of 455 total outcomes that might happen. So what we're doing here is we first have to apply the fundamental counting principle to essentially find out the numerator of my probability. This 6 is going to be the numerator in my probability because there's 6 ways to get what I want. And then there are 455 total options for drawing 3 balls. So I would on your notes write like what we want over the possible. What's up?
Why doesn't the 15 have the thing after it? Is it not supposed to, or is it just...
I think that's a typo.
Okay.
Where? Out there.
Let me check it. The 15 choose 3. Yeah, that should have a factorial. Good catch, Greg. This should have an exclamation point. So on your paper, please write that in. Please write that in so you do not later get confused. That 15 should have a factorial. That's a typo. So your probability of choosing what you want, those 3 balls, is 0.013 or just over 1%. That is very unlikely. Because it might not be that hard to draw 1, because that's 1 out of 15 chance. But then to draw 2 gets even harder, and to draw 3 of what you want is very difficult.
Isn't it dotted just the same thing, though?
Pretty much. It's close.
Wait, but
But isn't it the exact same?
yeah, don't you have to choose them in an order though?
Yeah, you have to choose them in, it says first the number 1, then the number 2,
Yeah.
then the number 3.
Yeah, so it makes it.
So now this makes it a permutation instead of a combination. So how many ways are there to choose my first ball first? Only 1. How many ways are there to choose the second ball second? Only 1. How many ways are there to choose the third ball third? Only 1. So now the possible ways that I can make this happen, instead of being 6, my fundamental counting principle here is really 1 times 1 times 1 for my first ball, my second ball, my third ball, because I want to draw them in order. So I really only have 1 possible outcome that I want. So this is my want, and I need to figure out my possible. But now how do I figure out my possible outcomes, Gail?
It's still 455 because it's still the 1 to 15 different balls.
Okay. Ooh, so does that make a difference whether it's now a permutation versus that it's a combination before? Choosing balls in order does change our options. So now it's a 15 permutate 3. And that gives me 2,730 options because when I care about order, I have more options. Because I could choose ball 579, ball 975, or ball 795 and still have all 3 of the same balls. Yes?
Just curious, what would happen if you had a negative factorial?
I mean, it doesn't make sense really. Like, situationally, it doesn't make sense. But, like, if you want just a numerical answer, if you had an even amount of numbers, they would come out positive still. If you had an odd amount of numbers, you'd come out negative. So now, I get 1 over 2,730, which has a decimal. I don't know why they don't give me that. A 0 point. This actually gave it to me in scientific notation because it's so small. You have less than a 1% chance. To be exact, you have 0.036% chance, or 7 if I rounded that 6 up. You are very, very, very unlikely to be able to do this. I have a friend who every time we're playing euchre, he will try to predict the first card that flips up. And he sometimes gets it right, which people are like, oh my gosh, you're a cheater, or you knew that. And really, his chances aren't that bad, because in euchre, there's not that many cards in the deck. Yeah, so to guess the number and the suit is really a 1 out of, what, are there 20 cards in euchre?
Yeah, you take out 32.
Yeah, so there's still 20. So you have a 5% chance. So when he does that, I'm like, Dave, you're not that impressive. Yeah.
This is what we have made us try to do this with like a deck of cards.
Yeah, this is just taking it further because now order matters. So we could do this, but we could say, what's the probability of choosing a 2 of diamonds, then a 3 of clubs, and then a 4 of hearts? And then that makes it a permutation. But, all right, that's all I got for you guys. So I got homework, and then you're out of here.
Yeah.
Excuse the interruption. Could I please have David Traveler to the office, David?
I've heard a rumor that Google Calculator can do combinations and permutations, but I'm not certain.
Robin, can you get us homework?
Could I also have the Michael to the office, Ben?
Too slow.
13-3 or what? What factorial?
This is 13-3.
Okay, 0 factorial.
Right in front of my face, and it was shiny.